But if you cover that 1 acre with a foot of water, that is an acre foot. An acre foot of water amounts to about 326,000 gallons. All right? We were talking about the Bighorn River. We talked about 2,500 CFS. That's cubic feet per second. How many acre feet per year does that amount to? It amounts to 1.8 million acre feet per year. We're going to go back to the 500,000, right, and the 300,000 here in just a minute. But you might be thinking, okay, how much water do I need for a crop to grow something, right? So I have an example here. Next. When you talk about how much water you need to grow a crop, you can go to the Extension Service, the Ag Extension Service, and you can inquire about a particular crop, say alfalfa. So I have an example here with alfalfa. So we have an allottee who has 35.4 acres, and they wish to put it into alfalfa. Here's a picture. Well, the alfalfa needs almost 23 inches of water, applied to the land over the irrigation season for that crop to grow. What we usually do is we take that depth of water, we spread it out over the area in acres, and we come up with the number of acre feet of water that are needed to grow the crop. So we have 67.3 acre feet of water required. Next slide, please. The problem is that almost all canals leak. And so if the canal leaks half of its water along the way, you're going to need twice that much water delivered to your place so that you can get what you need to grow that crop. And so now we're up to almost 135 acre feet of water needed from the canal system that's leaking. Well, if you divide that over the time of the season, you're going to need nearly 1 CFS of water for that alfalfa project. Next, please. This is really hard to see. I apologize for that. But if there's about 2.2 million acres on the reservation, and 46% is held by allottees, then we're talking about 1 million acres. All right? Let's say a third of the allottees' land was to be put into alfalfa. Using that example, they would need almost 1.3 million acre feet of water to grow alfalfa on 333,000 acres. The problem is that is way more water than the Bighorn River can sustain. It would ruin the habitat of the river if everyone decided that they were going to irrigate to alfalfa, for example. All right. Next, please. To help understand a little bit about the natural flow part of the discussion, I have this graph. I really apologize. It's kind of hard to see in this lighting. But there are these blue bars, and each of these blue bars represents how much CFS has gone down the Bighorn River in a year. So on this side we have 1990, and over here we have 2009. And you can see some years it went well above this green bar, and several years even went above this yellow bar. Well, the yellow bar is the 75-year average of 2,500 CFS. The green bar is the flow in the year 2000. The flow in the year 2000 was 2315, and that is what is being considered to be natural flow. So there's 500,000 acre feet reserved for the Crow tribe and Yellowtail Dam to be released, right, so that the water flow that's going down the river will be at or above natural flow and can be used for water projects. What you can see is that between the year 2000 and 2007, there were a lot of years in here because of the drought conditions where even if you released 500,000 acre-feet of water, you would not reach the natural flow level. And given the issue of global warming and climate change, we don't know what the future will be for our weather. We don't know if it will become more dry or wet or what, but there's a lot of concern about the future. You are making a decision now that will, are you taking into account the future? I'm just raising that as a point or a question. Okay. A month ago at that particular meeting in Billings, Vice Chairman Scott Russell said, very wisely so, he said, and as we speak, billions of gallons are going through our reservation and we're not getting 1 cent out of it. And that's true. Not only is it true for surface water, but it's true for groundwater. No one seems to be talking about groundwater in this discussion. So I wish to speak next then of the groundwater resources that exist on the reservation. There are two kinds of groundwater that can be found on the reservation. That's the water that's very near the surface. So as precipitation falls to the earth, some of it seeps into the ground, and it continues to seep downward until it encounters a layer of clay or bedrock or something where the water can't go through it very easily, so it starts to pile up, and then it stabilizes at some position that we know as the water table. So if we were to get a drill rig right outside the building and drill down, you would probably hit water at about 20 feet, 30 feet, something like that, right? You could drill a well and you would find water. This is the water near the surface, water table aquifer or scenario. Okay, next please. There is also water that is very deep beneath our feet. This is water that had its beginnings up in the mountains. There are places where rock strata or rock layers are exposed up in the mountains, up at the surface, where there's a lot more rain and snow that falls down here in the plains. These areas are called recharge areas. Let's see what happens. Okay, so recharge. Okay, go ahead next. Recharge waters go into the aquifer, and then the water flows down that strata layer, if you will, and it goes across the reservation. Next slide. Here's a picture of the Bighorn Mountains, and this is the recharge area, if you will, for several rock strata layers that are very important. Here's one, for example, known as the Madison layer. There is enough water in the Madison to drill one well and supply enough water for the town of Lodgegrass and Crow Agency, and you could build a pipeline that went down the highway. Clearly this project would cost $20 to $30 million, but it seems to me that if the federal government fails